Hello everyone. In this class, we will discuss two more examples on Fourier series of even and odd function in the interval minus pi to pi. This is the third example. Question is, find Fourier series for the function f of x is equal to 1 plus 2x by pi in minus pi is less than x is less than 0 and 1 minus 2x by pi in 0 is less than x is less than pi. Means f of x is equal to 1 plus 2x by pi when x lies between minus pi and 0, and f of x is equal to 1 minus 2x by pi when x is lies between 0 and pi. Before applying the formulas, first we have to check here whether the given function is even or odd. Given function is given f of x is equal to 1 plus 2x by pi in x is greater than minus pi and less than 0 and 1 minus 2x by pi in x is greater than 0 less than pi. If to check whether the given function is even or odd, if we consider phi of x as 1 plus 2x by pi and psi of x as 1 minus 2x by pi, then we have to check f of psi of minus x is equal to 1 minus, we will take another step, 1 plus 2 into this is minus x divided by pi, which is equal to, see here, 1 plus into minus minus 2x divided by pi, which is same as psi of x, which is equal to psi of x. Therefore f of x is even function. When we substitute x as a minus x, we get this function as a psi of x. That means phi of minus x is equal to psi of x, so that the given function is even. Hence we have, when it is even, we know that Bn e value is 0 and a naught is equal to what? A naught is equal to 2 by pi integration from 0 to pi f of x dx, and an is equal to 2 by pi integration from 0 to pi f of x cos nx dx, and Bn is 0. Okay. Next we have to find the a naught, an. For that, now a naught is equal to what? 2 by pi integration from 0 to pi f of x dx, which is equal to 2 by pi. For the limits 0 to pi, f of x is 1 minus 2x by pi into dx. Now we have to integrate this one. 2 by pi is constant. We know that integration of 1 is x and integration of x is x square by 2. Therefore, a naught is equal to 2 by pi integration of 1 is x minus 2 by pi as it is into integration of x square. X is x square divided by 2, limits from 0 to pi. 2 get cancelled. 2 divided by pi, remaining is x minus x square divided by pi, limits from 0 to pi. Now apply the limits. First we have to apply the upper limit, then minus lower limit. Apply upper limit. Upper limit is pi. Pi minus pi square divided by pi. Then upper limit is over, minus this is whole is 0. This is 0, minus 0 divided by something is again 0. Therefore lower limit whole term is 0, which is equal to 2 by pi. Pi minus 1 pi cancel with this denominator pi. Therefore it is pi minus pi. Pi minus pi is 0. 0 into something is again 0. Therefore a0 value is 0. Next we have to find the bn. Next is bn, sorry, not bn, an. We know that an is equal to 2 by pi integration from 0 to pi f of x into cos nx dx. Again for the limit 0 to pi, our f of x is 1 minus 2x by pi. An is equal to 2 by pi, limits from 0 to pi. F of x is 1 minus 2x by pi into cos nx dx. To solve this one, we have to use the Bernoulli's rule. Applying Bernoulli's rule, we get an is equal to 2 by pi is as it is. Okay, now this is a square bracket. Now keep this, consider 1 minus 2x by pi as a differentiating part and cos nx as a integrating part. For that we have to first keep as it is the differentiating part. We have to integrate the integrating part. We know that integration of cos nx is sin nx divided by n. Then minus, differentiate this one. Differentiation of 1 is 0, minus differentiation of x is 1. Here minus is there, therefore it is minus 2 by pi. Again we have to integrate this one. It will be minus cos nx divided by, here we have n already, n into n is n square, limits from 0 to pi. If we write the next term, it will be 0 because differentiation of this constant is 0. 0 into something is 0. So that you have to stop here only. Then an is equal to 2 by pi as it is, 1 minus 2x by pi into sin nx divided by n. This is minus, minus into minus plus, it will be 2 cos nx divided by n square into pi, limits from 0 to pi. See here, we know that sin pi is 0 and cos 0 is also 0. So that when we apply these limits, this first term will be 0. Because sin pi value is 0 and cos sin 0 value is 0. So that when we apply upper limit and lower limit, both will be 0. Therefore this whole term, first term gives us 0. So that we have to apply only limits for this second term. In this second term, we have to take minus 2 divided by n square pi outside the limits, because these are constants. After taking these constants outside the limits, we get an is equal to 2 by pi. I will write only the second term. This is minus 2 cos n x divided by pi n square into pi, limits from 0 to pi. It will be minus 4 divided by n square into pi square. Only we have to apply the limits for cos nx. It is 0 to pi, which is equal to minus 4 divided by n square pi square. Upper limit first we have to apply cos n pi minus cos 0. Okay, we know that since cos pi value is minus 1, here we have minus 1, but cos n pi, here we have n pi, therefore it is a minus 1 raised to n, and cos 0 is 1. Therefore an is equal to minus 4 by n square pi square into minus 1 raised to n minus 1. Take this minus here, means multiply this negative sign to this bracket, we get 4 into 1 minus of minus 1 raised to n divided by n square pi square. Therefore an is what? 4 into 1 minus of minus 1 raised to n divided by n square pi square. Now substituting the Fourier coefficients in the f of x is equal to a naught by 2 plus summation n running from 1 to infinity an cos nx plus summation n running from 1 to infinity bn sin n x. Since bn is 0, this last term is 0, so that f of x is equal to a naught is 0, therefore it is 0 plus summation n running from 1 to infinity an is 4 into 1 minus of minus 1 raised to n divided by pi n square pi square. 4 by pi square is constant. We can write it as f of x is equal to 4 by pi square summation n running from 1 to infinity, because we are substituting values for n here, therefore it is 1 minus of minus 1 raised to n divided by n square. This is the required Fourier series for the given function. That is f of x is equal to 4 by pi square into summation n running from 1 to infinity 1 minus of minus 1 raised to n divided by n square. Next example. Find the Fourier series in interval minus pi comma pi for the function f of x defined by f of x is equal to pi plus x in minus pi comma minus pi by 2. Pi by 2 when it is minus pi by when it lies between minus pi by 2 comma pi by 2, and pi minus x in pi by 2 comma pi. Here our given function have three sub function, that is pi plus x, pi by 2, pi minus x, and given the different intervals. Finally our given f of x is defined in the interval minus pi comma pi. Solution: f of x is defined in minus pi comma pi, and the Fourier series of period 2 pi is given by our Fourier series. Required Fourier series is f of x is equal to a0 by 2 plus summation n running from 1 to infinity a n cos nx plus summation n running from 1 to infinity b n sin nx, which is equation 1. Now we have to check whether the given function is even or odd. For that we have to write the f of x as follows. Intervals of x is, we have the three different intervals. I will write these three intervals like this. First is minus pi comma minus pi by 2, and minus pi by 2 comma 0, 0 comma 5 by 2, pi by 2 comma 0. See here, when the interval having the f of x having minus pi by 2 comma minus pi comma minus pi by 2, our f of x is what? Pi plus x. See, when the f of x is defined in the interval minus pi comma minus pi by 2, f of x is pi plus x, and when it is minus pi by 2 to 0, here the second pi by 2, f of x is pi by 2, when it is lies in minus pi by 2 comma pi by 2. Minus pi by 2 comma pi by 2 means when we take the interval minus pi by 2 comma 0, the f of x will be pi by 2. Again when we take it is 0 to pi by 2, f of x is pi by 2, and for pi by 2 comma pi it is pi minus x. Okay. To check the nature of the given f of x, we have to write the given f of x like this. Now consider f of x is equal to phi of x in minus pi comma 0 and psi of x in 0 comma pi. F of x is phi of x when phi of x is lies between minus pi to 0, and psi of x when it lies between 0 and pi, where we have to take the given f of x, where our phi of x is equal to, you may take pi plus x or pi by 2, because pi plus x lies between minus pi comma minus pi by 2, and pi by 2 lies in minus pi by 2 to 0. See here we have phi of x is in minus pi comma 0, so that these two functions lies in minus pi comma 0, because pi plus x lies in minus pi comma minus pi by 2, and pi by 2 lies in minus pi by 2 comma 0, so that phi of x can be taken as phi plus x, pi plus x or pi by 2, and psi of x is equal to x, we have to take, we may take pi minus x or pi by 2, because see here psi of x is in 0 comma pi, our pi by 2 is in 0 comma pi by 2, and pi by 2 comma in pi by 2 comma pi it is pi minus x, so that we can take psi of x as a pi minus x or pi by 2. Now we have to check the nature of this given function, means we have to check whether the given function is even or odd. Therefore phi of minus x is equal to pi minus x, which is psi of x, otherwise psi of x is equal to pi by 2, because pi by 2 is constant, we don't have any variable here, means x. Therefore phi of x and psi of x both are pi by 2. Hence we conclude that f of x is even. When it is even, a0 is equal to 2 by pi integration from 0 to pi f of x dx, and an is equal to 2 by pi integration from 0 to pi f of x cos nx dx, and bn value is 0. Now a naught is equal to 2 by pi integration from 0 to pi f of x dx. This limits 0 to pi can be written as 2 by pi integration from 0 to pi by 2 f of x dx plus integration from pi by 2 to 0 f of x dx, because in our example given f of x are lies between 0 to pi by 2 and pi by 2 to pi, so that we have to take the integration 0 to pi as 0 to pi by 2 f of x dx plus pi by 2 to 0, pi by 2 to 0 not 0, it is pi f of x dx. Now 2 by pi into, when f of x is in 0 to pi by 2, f of x value is pi by 2 dx, plus when it is in pi by 2 to pi, f of x value is pi minus x into dx, which is equal to first integrating the first term. Here pi by 2 is constant, integration of constant is x, limits from 0 to pi by 2 plus this into pi is constant, this is pi into x minus x square by 2, limits from pi by 2 to pi, which is equal to 2 by pi by 2 as it is. When we apply upper limit, it is pi by 2, this is 0, this is over, plus apply upper limit pi into pi minus pi square by 2. Upper limit is over. Next we have to apply the lower limit, minus lower limit is pi into pi by 2 minus pi square by 4 divided by 2, because we have x square here, therefore pi square pi, it will be pi square by 4 divided by 2. Now simplify 2 by pi into pi square by 2 into pi square by pi by 2 into pi by 2 is pi square by 4, which is 0, plus this will be pi square minus pi square by 2 minus lower limit is, it will be pi into pi square by 2 minus pi square to 4 into 2 is 8, pi square by 8. This is for the second term. First simplify the term. A naught is equal to 2 by pi as it is. First term is pi square by 4 plus pi square, plus into minus, minus pi square by 2 minus pi square by 2, then minus into minus plus pi square divided by 8. Now which is equal to 2 by pi pi square by 4 plus pi square. Here it is minus pi square by 2 minus pi square by 2 minus 2 pi square divided by 2 plus pi square divided by 8. 2 get cancelled. 2 divided by pi, it will be 2 pi square by 4. 2 get cancelled here. Remaining is pi square minus pi plus pi square by 8. Plus pi square minus pi square get cancelled. 2 by pi into pi square by 4 plus pi square by 8. Take the LCM. 2 pi pi, LCM is 8. This is a 2 pi square plus pi square, which is equal to 2 by pi 3 pi square divided by 8, which is equal to 1 pi cancel with this denominator pi to numerator. It will be then 2 ones are 2 fours are, it will be 3 pi divided by 4 is the A naught. In our Fourier series we have A naught by 2 term, so that we have to find A naught by 2, which is equal to 3 by pi, means multiplying 1 by 2 on the both side, we get A naught by 2 is equal to 3 pi by 8. Similarly, we have to find AN. To find AN, next to find AN is equal to integration 2 by pi 0 to pi f of x into cos nx dx. Here also we have to split the limits as 0 to pi by 2 to and pi by 2 to x, and substitute f of x for 0 to pi by 2, it is pi by 2. When it is minus pi by integration from minus pi by 2 to pi is pi minus x into cos nx dx. Here pi by 2 is a constant, take outside the integration. We have to just integrate cos nx dx plus integration from minus pi by 2 to pi minus pi minus x into cos nx dx. To simplify this one, we have to use the Bernoulli's rule. Applying Bernoulli's rule for the second integral, an is equal to 2 by pi by 2 as it is, integration of cos nx dx is sin nx divided by n, limits from 0 to pi by 2, plus we have to apply here Bernoulli's rule. Consider this as a differentiating part and this is a integrating part. We have to keep differentiating part as it is. Integrate cos nx is integration of cos nx is sin nx, here sin nx divided by n, limits from pi by 2 to pi, minus, for now differentiate this one, it is minus 1 into, again integrate this one, minus cos nx divided by n into n is n square, limits from pi by 2 to pi. Second next term will be 0, so that you have to stop here only. Now an is equal to 2 by pi, here it is pi by 2 into n, apply the limits. Upper limit it is sin n pi by 2 minus 0, because sin 0 is 0, plus apply upper limit to this one and take 1 by n outside. When we apply upper limit, it will be 0, because sin pi value is 0, so that for when we apply upper limit, the whole term will be 0, minus apply lower limit pi minus pi by 2 into sin n pi by 2. Then for this one, this is a minus into minus plus, here we have negative sign, therefore it is a minus 1 by n square. While applying the limits, cos n pi minus cos n pi by 2. Now see here, when we multiply the terms, it will be pi by 2n into sin n pi by 2. It will be plus into minus minus 1 by n, and pi minus pi by 2, it is again pi by 2 sin n pi by 2. The last term is as it is, and sin n pi value is minus 1 raised to n. We have to apply those results. We get, it will be n is equal to 2 by pi into pi by 2n into sin n pi by 2 minus 1 by n into pi by 2 into sin n pi by 2 minus 1 by n square into minus 1 raised to n cos n pi by 2. 1 by 2 by pi, pi by into pi by 2n into sin n pi by 2, my 1 by n into 2 by pi by 2, it is pi by 2n sin n pi by 2. It is a plus pi by 2n sin n pi by 2 minus pi by 2n into sin n pi by 2 get cancelled, minus 1 by n square minus 1 raised to n minus sin cos n pi by 2 as it is. Take my 1 divided by minus 1 by n square outside. It will be an is equal to minus 2 by pi n square into minus 1 raised to n minus cos n pi by 2. This is an. Now substituting the a0 an bn value in a Fourier series, that is, which is equation 1, f of x is equal to 3 pi by 8 plus summation n running from 1 to infinity minus 2 divided by pi n square minus 1 raised to n minus cos n pi by 2 into cos nx. This can be written as f of x is equal to 3 pi by 8 minus 2 by pi summation n running from 1 to infinity 1 by n square into minus 1 raised to n minus cos n pi by 2 into cos nx cos nx. This is the required Fourier series for the given function.